number 2415, which is reverse odd level binary tree. Basically what we have a binary tree which is a perfect binary tree. Like if you look at this binary tree, like if a level exists, all of the nodes above that level will have two child. For example, if you have this one, and you can't have like this, okay, if this is your root node or any node, so it's you can't have one child, you should have two child or no child, as you can see. So let me rub it. As you can see, uh, at the last node they don't have any child, or if this will be having any child, let's say 64, so this won't be a perfect tree, a perfect binary tree, sorry. So you understand what is perfect binary tree? Then what this question is asking basically is reverse the odd level binary tree, which means like if you look at this tree, you can look it as a level or a different, like a story, like in your house you have different floors. So look it just like that, like this is your zero floor, this is your first, this is your second, and this is your third. So basically what this question wants from us is to swap or reverse the nodes and at the odd level. For example, if you see this is odd level 1, this 3 is also odd level. If we reverse this 1 and 2, so on the left we have 1 and on the right we have 2. But if we reverse, so on the left we have 2 and on the right we have 1. And if you look at the last, you can say level or the third level, so basically we have 7, 8, 9, 10, 11, 12, 13, 14. These all are the nodes. If we reverse it, so this will be 14, 13, 12, 11, 10, 9, 8, 7. So basically just reverse. So you think how to approach this problem? It's pretty simple to just mark up the answer, but I'll try to explain you if you can understand. I'll try my best. So basically it's asking to reverse the odd level. The first thing that you can think is how to know if the level is odd. So you need some variable to keep track of the level that you are currently on. Like if you are at the 0th level, you can have any variable, let's say variable name level, which will start from 0. So if you see, it is, if modulo by 2 is equals to 0, it will be even. But if it is not equals to 0, which will be odd, so you can reverse the your node. So you are trying to grasp how to just reverse the node. Like you have to, whenever you see a 1, 3 or variable or value which is modulo 2 is not equals to 0, you can reverse the node. How to reverse that? That is a different case. So let's see. So how to reverse? So like if you are at this position, basically you should have track of all the nodes at that level. Like if you want to solve 1 and 2, you must have 1 and 2 with you so that you can solve the values. So how can you have the values, or how can you keep the track of those two values or multiple values? So the simple answer, I'll suggest, if you watch my zigzag traversal video, which was from left to right, then right to left, then left to right. So basically what you can do, you can have an array and a queue. This is your queue, this is your array. The code is pretty similar. So like first you push your root node, and then you'll do a BFS traversal. Like you'll go to the next and you'll push its child. Like child will be 1 and 2. You won't do anything with 0, as it is on the even level. Let us suppose your level is 0. You won't do anything. If it's changed to 1, what you have to do, like you have to pop this, then you'll put its side. So basically what you did, let me explain again. So you are at level 0. Then you want to uh, push it child, or first you will check if you are on odd level or even. You are at the even level, you don't want to reverse anything, you just want to push it child. So you push it child just like this. You'll update the level because you reached to the odd level now. Now when you are at 1, or you can say it's child, you're here. Then basically what you want to create an array. Okay, like it will be having track of the current elements. Okay, at that level only, like this one level is having these two elements, so you can create a temporary array. Let us suppose names is a temp. Okay, so like, and you will traverse through the each node in the queue, like this is your 0 index, in the 1 index 0 and 1 here. So what you'll do, like if level is odd, you want to switch the value, you want to have 2 here. So the value at this position will be the last value. So what you can have is node or the node at the front of the queue, node arrow val, which will be corresponding to value, which can be equals to the temporary array. I hope this is visible. Temporary size, like if you are at this position, you want to basically here. So how you get to size minus 1 minus of I. If you can't understand this, so I'll recommend basically just to watch the zigzag traverser video. It will make it more clear. So like in the queue, you are at, like you popped this, just remove this. Okay, this is not in your queue now. So at you are at the first position of the queue, of the front of the queue, you popped 1, or you are at 1. Basically what you want, you found out you are at the odd level, you want to push or you want to have reverse the value. So you have track of all the value at that level, at the first level. So what you want to exchange its value from the back of the temporary array. So this is how you do it. Like this will be your node, it will be pointing to the node, as we are not just shifting the you can say the nodes, you are just shifting the values. That's why we are using node arrow val, and the temp is the temporary array we are creating for. And then what we'll do, you'll pop 1, you'll push its child, which is 3 4. Then similarly you'll do with 2. So 2, like it is at the first position. Okay, so at this, like this is your node, let us suppose. Let me be more visual. This is a node. What you want here, basically you want 1, and how you getting 1? So at here you will be solved, like let me just solve. Temporary array size is 2 minus 1 minus I is a position that we are currently at. We are here, so you can see it's 1 minus 1. So this will give 0. Temp of 0. At temp of 0 we have 1. So we will put 1 here. So it will become this. And its child will remain same. Okay. So you found out you are doing basically nothing, but you are just swapping the value. Okay. I hope this approach is clearer and pretty clean. I'll prefer this approach basically, but the problem with this approach is the space complexity, as we are using an additional data structure array, so it will be big O of n. So if the interviewer asks us like how to optimize this approach, so let me just break down, or we should just focus on the tree more. Like if you look what we are doing, like at a level, let me just show you. Like if you are at this level, okay, then what you are doing, you are just having one or the value of that level, you are swapping the value. Or if you are at this third level, which is 7, 8, 9, 10, 11, 12, 13, 14. This was your array, that you can suppose an array, and you just reverse it and you can have it here. If we look closely, what we are doing, like this is your original value, and after reversing, what you will be having. I hope this part is also visible. So if you reverse it, basically you will be having this. Let me be more clear, because my writing is not that clear. So 14, 13, 12, 11, 10, 9, 8, 7. Okay. So this, you are just reversing it. So if you look closely, what you are doing? You are taking the leftmost value, you are taking the rightmost value. And what you are doing? You are doing nothing but a swap. Okay, you can see 7 and 14. You just swapped. 7 came at the last position, 14 came at the first position. Similarly with the 1 and 2. 1 was here, 2 was here, and you swap it, so it will become 2 and 1. Okay, and if you keep looking, 8, we take the next value, and 13, we swap it, 8 came here and 13 came here, and up similarly followed with the 9 and 12 and 10 and 11, and so on with all the odd levels. So you think, what we are doing, like if we are at a level, so what we want, like we found out, if we are at the odd level, we want to swap basically. So if we are at the odd level, what we can do, like just write the pseudo code. If we have some function f which have a left node and a right node, so we can say r1 and r2. Get rid of this also, so it won't distract. It's pretty simple. I hope you are understanding. If you couldn't, just rewind it so you can understand. And a level variable which will be keeping track of the level is pretty simple. So you can think of recursion also. And firstly, let me just write, like if you are on odd level, so basically what you want to swap the values. How you'll swap? You'll simply use swap function. I'll use just arrow here, r1 dot val, r2 arrow val. Okay, you're swapping. After swapping, like what you are doing, you are going next, like let me run this. Like if this was your r2, this was your r1, like you found out they are at level 1, or which is odd level, so you swap the values. Okay, then what you came here, like one possibility you can have with 3 and 6. Like as I said, if you want to swap, you'll swap the outmost value or the inmost value. Okay, I hope you're understanding. Like let me just draw this array. 9, 12, 13, 14, 13, 12, 11, 10. So you are swapping the outmost value. How you are swapping outmost value? You are again calling recursion, and for a left, like if you see, we changed 7 with 14. Okay, which is the leftmost value of this side. Like after 1, like we swapped 1, basically 1 and 2, we came at the leftmost side. We didn't did anything because this is odd level or even level. Just we came here at the odd level, uh, and we are going at the leftmost value, as you can see, because we are stopping at the array leftmost value with the rightmost value. Okay, this can be a case ki r1 arrow left, we are going left in the r1, and for r2 we are going at the rightmost value, and we will increase height or level plus 1. Don't worry about the code, I'll show you the code. And just look, you swapped 7 and 14, so you can see 14 came at the place of 7 and 7 went for the place of 14. What about 8 and 30? If you look, like, if we were at this level, then we came at this level, one position, like one was the going at the outmost values, and next was going at the in values, like inside that node, like, or towards the end of the tree, I can say, which is pretty imaginary, but yeah, inside of the tree. So like if you are standing here, so like let us suppose this was your r1 in the previous equation case, and this was your r2. So like you went at the left, like you can see here 7, and for r2 you went right 14, you solved. And the other possibility that you can have is you can go right with r1, which will give you 8, and left with r2, which will give you 13. So r1 arrow right, comma r2 comma left, r2 arrow left. I love this. Okay, and you'll end if r1 या फिर r2 equals to null. Okay, this is just the pseudocode. I'll show you the code, and it's simply written. I hope you understand. Like, I won't prefer to mug up this solution. I'll just suggest you to see the zigzag traversal, then try to relate with the array, like how, because whenever there is a level order traversal on left and right, so there is always BFS involved. Like we were traversing through a level which is breadth first search, and we have to reverse it. So reversing, simply you can use array, as I told, just store all the values, and for traversing in each value of the queue you can choose from the last. Okay, that was pretty simple. And if you are asked to optimize, you can use this approach, and you can think of this approach. So let me show you the code. This is the level 1 or odd level, so we are swapping 3 and 5, and so this is the code. So let me just iterate the code, or just give you a try run. So basically we are checking if root is null, we'll return the root, and when we are passing the left of the root and right of the root with level 1, as they are at the level 1. Simple, easy to get. Then what we came at this function, forget this one now. We checked if we are at odd level or not. If we are at odd level, simply we'll swap the value of the node. Like for example, if we are at level 1, 3 and 5, we'll swap the value. Okay, after swapping the value, what we want, like for r1, which is 3, we want to go at the leftmost value, and for the r2 we want to go at the rightmost value. Like you can see, r1 leftmost value, r2 rightmost value, with increase the level. And second possibility can be we went in the right of r1 and left of r2, basically choosing from the inner part of the tree. You can say r1 arrow right and r2 arrow left, you can see here, and level plus 1. So when we will end, like if we reach null value, like let us suppose r1 is here and r2 is here, we came next, r2 is null and r1 is null. If any of that is null, we understand like we have reached at the dead end, like there's no further node, so basically we'll return. So code was pretty self-explanatory. So thanks for watching.